Yes, name's Andrew. Talking about the science, laser precise drone flights. So why lasers? Why drones? Alec did a really good job in explaining what we're doing in the lab, but just to kind of, I guess, give a slightly more dumbed down version. Um, the way I like to view it, because I was pretty hard to understand myself, is radio telescopes are basically these huge eyeballs into the sky, just at a different wavelength. And just like any other eyeballs, sometimes it needs glasses. But so what normally happen with tinier dishes is it'll be skewed to different sources that we know really, really well. And then from there, we collect some cool data, and then with some code, with that data, we fix the telescope basically, like give it lenses so it can better view the universe more accurately, kind of. But with these huge this pretty big. I know that it's not like as big as the image, but like it's bigger in real life. it, it basically is too big to move. So how do you do this? This is kind of where our drone stuff comes in. What we basically do is we take these drones and we kind of, with a radio source that we know really well, and then we kind of fly it over, sort of mimicking this pattern, but instead of moving the telescope to the object, we're moving the object around different points in the telescope to again kind of map out that like lens you'll see in glasses, and then for the telescope to basically see better. And my work is, and this is a new drone in the lab, so it's basically like we're using a previous one that crashed into a tree. Don't worry about it. But we have this new drone, and my job is basically understanding it, learning it, helping people also understand it, and these are our omnipotent leaders that we obey everything we're told from. Again, newly minted doctorate symbol. I camera the telescope, and this is that's in Newburgh. She has been so helpful, just like he knows so much about just like everything. And then so he like kind of created everything we're kind of working on now. So like if we have any problems that we're like doing, we just go to him because like he literally like started everything that we're present day working on. Data. I'm not gonna get too much into specifics. If you want to know, you can ask me after the question. This is an example of some of the LiDAR testing we did. This will go into the laser right after this. But I guess to kind of discuss the research, a lot of the data, which I really like about it, is not just like the actual numbers, but it's also like you're looking at the data and you're trying to figure out what it means, and what happens, why it's weird this way. It's really a lot of detective work, kind of why is it 0.45 meters off? Why do you see it as it increases in elevation? You see that discrepancy getting higher. Is that something with the lasers? That's something with the setup. It's not perfect world scenarios. That's something potentially with the weather and the wind drift. Do you remember anything from the flight and all the pictures you've taken? Because you have to take a bunch of pictures while you're setting up to see if you did something wrong with the setup. Is there anything wrong with the discrepancy there to look it over? It's a lot of like kind of figuring out where you did wrong and how that shows in the data. And actually, no, the opposite. Looking at the data and see where you did wrong that I really enjoy personally. It's a lot of like creative thinking. You know, let's get that. So a bit about that actual work. I really like this photo. This is really cool. I hope so in the previous presentation. But a lot of the point what I was doing, I've been here for about 4-ish weeks now. We do a lot of stuff. One of my things is basically using lasers to better understand art. So you know, we talked about previously the drone flying with the digital stuff like that. Finding out where exactly it is a lot harder than you think. And what I'm using is basically making several different like lasers and data logging tools in order to basically bounce back the signal. You guys know a ladder is you bounce down a laser back using the known speed and using the known speed of light and the time it takes. You can calculate the distance and basically seeing how the positional accuracy of the drone, how accurate it is, how it changes during flights, is there anything weird we should know about? Because you can't trust everything that's in a data sheet. So half of it, I think a lot of my part was actually designing and building the LiDAR system. It was actually pretty simple. It was just like a laser, Arduino, some other things. Then here's a little setup. I don't know if you guys see me in like that big hallway. I know a lot of people pass by, but it's basically testing if the LiDAR is accurate with another LiDAR that we don't exactly know if it's accurate, but then using the floor tiles and the floor tiles. Anyways, measurements are social concept. But yeah, no, it's basically me here taking the LiDAR, putting a little setup and seeing how accurate the LiDAR is based on like how with a ruler and how much floor it is. So that was a lot of time better actually understanding lasers and like how well they are in you. Then here's us actually flying the drones, learning how to fly it. Then this is me implementing it for one of the experiments. Actually, what mainly my research was supposed to be on was drone heights. Here's the little laser setup pointing up towards the drone, a little plank. We ended up changing this a little bit to make it a little better, pointing it downwards. But this is it in action. This is posing for the feed. This is John's experiments. So initially, my whole summer, all the 10 weeks was supposed to be spent on just figuring out the drone height. That has since passed. So we've added some new things to better understand the drone's location. Okay, so the drone height is, as you can imagine, one of the hardest parts. There are so many annoying factors you have to take into consideration when it comes to like understanding the actual factual drone height of it. That's what we were saying previously in the previous slide. I don't know if I can, of like the laser pointing up towards the drone pointing down. That's what didn't work too well, but we got it figured out. So that was the hardest part. Moving on, we're trying to better understand the absolute location. So like when you look into like the GPS and telemetry data from the drone, how much that actually matches up with real life. This you're basically just putting it on a marker, you know, and just letting it sit for a while. But it's a cool vacation trip we're gonna take, like not like really 5 miles away from your interview up on marker. This one, return to home, we're basically trying to understand how the drone drifts over time throughout a flight. Again, rather than going through all this, I'll just tell you the main summary of it. It's really to better understand how the drone views the world from a relative framework, and then how accurate it actually is, like from like longitude and latitude. So that's what these, I'll probably be spending the rest of my summer now that this is done, focusing on those 3 months. Important points. Again, I've only worked here for 4 weeks, so the research I'm only not even halfway done. But some things I've learned: time and precision are truly not real. Like it's like, okay, you have a LiDAR system that gives you this measurement, but you don't know if that's exactly right. So you have to test it on something else that is slightly more accurate, but that laser is also probably not completely right. So then you have to use a ruler. But if you ever got 2 rulers and put them together, those 2 rulers are never actually exactly matched. So then you got to use another thing. And then you look at like time clocks and they're not usually matching up. Anyways, but it's something very important experimental where like everything is really based on like a relative marker or point. And you basically are testing all of your accuracies on something you hopefully know really well. Drones are dangerous. This is actually a large part of what I've been doing, like hundreds and hundreds of pages of manuals of like FAA law and regulations, how the drone actually operates, and then trying to simplify that down to better explain to people. That's a lot of reading and a lot of like understanding safety and like people not getting hurt or damaged in the drones and part of it. Never trust a manufacturer, they're thieves and slumps. Not this that said it could go like 100 meters hour, some crazy thing like that. It could go like 30. And don't get charged with batteries. That's very important. Yeah, that's kind of concludes that. Okay.
Yeah. So I happen to know, because I may or may not be a part of this lab, that to fly the drone, it will, especially with wind, will tilt. And I wanted to know how that would affect the LiDAR system and how you dealt with that.
Yeah, so that's actually a very fascinating point. One of the many things you have to consider. With wind specifically, however, when a horizontal vector is placed within the drone, it tilts slightly at an angle so it's such that it doesn't like its speed that way, actually creates a torque motion. It torques around the center pivot point, or like the center axis. So like you guys know what like center gravity is. And just imagine that like 2D on length and it pivots that way. So what we actually ended up doing was mounting the LiDAR system onto the drone. And as long as you put it in that central axis, like really well, I took like a string on the drone one time and like I kind of saw where it was, put it in that center axis very well. The LiDAR doesn't actually move because if you imagine it as the drone pivots, if you look at it infinitesimally like tiny line, that line stays stationary. So that was one of the ways. Additionally, if there was a major gust of wind, I recorded it on my phone like this, and see that emulated within the data. But any discrepancies I saw were very minute, and there were larger factors that we had to actually figure out for the data. And especially there were too small. The discrepancies I saw in the data were a lot smaller. Were so small that I really didn't have to care about it because the margins of accuracy in which Laura needed the experiment were bigger. Yeah. That was, I think that's, yeah.
So the measurements you might have taken would be at different days with different weather conditions. So which you mentioned that the measurements are relative and all the instruments have different ways of measuring, say, the height. So did you see any difference in the height measured by the drone and the LiDAR in your different experiments? Do you expect to, or say the humidity is higher? Does that change the drone's height measurement or no?
That's a really interesting question, because especially the height, we weren't interested in its the height, it absolutely no more relative of how it changes with different elevations and things like that. One of the things we're kind of gonna test, this will be a long answer. One of the things we're gonna test in experiment 4 is how the drone height, if it changes with barometric pressure. Barometric pressure is basically, think of it like the pressure the atmosphere imposes on you, and that changes with like humidity, the amount of water, the amount of temperature, dew point, whatever dew point is, so figure it out. And basically, what we don't understand, and one of the questions we're trying to figure out is whether large changes in barometric pressure changes the height of a drone throughout time. When we're doing experiments, with your question with temperature did not matter because the barometric pressure stayed fairly constant, especially throughout the afternoon. And so the measurements that the drone took at the start of takeoff were basically the same at the end of takeoff. So there would be no changes in height to take account. But a lot of these drones, like you imagine, such a large area, will be significantly larger. So barometric pressure has an opportunity to change. So one of the things we're figuring out if that actually changes the height measurements the drone is taking, and I have a few ideas on how to set that up. But long story short, for our experiments, no, we did not saw any change because the nature of the flights were very short. Whether we can see that in a longer term flight, has yet to be figured out.
Thank you, Andrew.